Hello, my name is Richard Evans, Regional Sales Manager for Foster & Freeman Limited, and today I'm here to talk to you about our DCS5 fingerprint imaging system. Before we begin, we'd just like to do a little bit of housekeeping. So for those of you joining us today, first of all, welcome. All our guests will be muted because there's so many people attending the webinars, but you will have a chance to ask questions at the end during our question and answer session, and we'll answer as many questions as we can. And for those people who we are unable to answer the questions, please feel free to email us at sales@fosterfreeman.com, and we will do our very best to answer those questions. So DCS5. This is our latest flagship fingerprint photography system. But it's not just limited to fingerprints, it can be used for shoe prints and many, many other evidence types as well. It's a comprehensive imaging system, and it was actually one of the first digital imaging systems to be used by the police to capture digital images of evidence. And the first DCS, which was the DCS 1-to-1, was actually released back in 1999. And it was a sort of joint development project between Foster & Freeman and the police in the United Kingdom. So the DCS was actually developed with the police for use by the police. And I think that's one of the things that makes it very, very special today. Like many of our products over the years, we've updated them, and in 2003 we upgraded the system to DCS3. In 2008 we upgraded to DCS4, and then more recently we upgraded to DCS5, which was perhaps one of the most significant updates, because for the first time now we were able to do both visible, ultraviolet and infrared imaging. Now, DCS has been a fantastic success, and it's installed in more than 50 countries around the world. And in many countries there are many large scale installations. UK 190 systems, USA 90 systems, China 54, Italy 27, Colombia 21. So DCSs are used all over the world on almost every continent there is. And the customer feedback is really, really positive. We find that people that buy one DCS system will come back and buy more because it performs the way they want it to perform, simplifying their work, making their workflows much easier and quicker. One of the questions we often get asked is, what exactly is DCS? Many people think of it as like a camera and a computer, and it's actually a lot more than that. And perhaps the easiest way to think about it is that the DCS can be broken down into three different product areas. So first of all, we have the camera system, and the current DCS5 is based on the Nikon D5 that you see here. And then we have the illumination, and the illumination is perhaps the most important part of the system. If you don't get the illumination right, the camera cannot capture a good image, and then the software cannot enhance it. So the illumination is a very, very comprehensive mix, and it's supplied with visible, UV and infrared, depending on how you buy the system. The system is upgradable. It's actually sold in many different kits, so you can start with a simple kit, and you can build the kit up as your budget allows, as you'll see. And then the final part is the PC and software. And the PC and software does many things, such as enhancing the images, but it also does things such as audit trails and image authentication, protecting your digital images so that when you take them to court, you can prove that they have not been altered, and also have a record of what has been done to enhance the images. So we can start off with what we call a DCS core system. For most people, this is a basic DCS. Normally, it is doing just visible imaging. And then there are many different components that we can add onto the DCS system. Reflected UV, for example, visible fluorescence, infrared imaging, and then we have more dedicated kits such as CSU, which is for imaging the bullets and other round items, bullet cartridges. We have a tilt and shift lens, which is useful for on curved objects. We have a footwear module, which includes some lighting to be able to see, for example, shoe prints in dust. We have a digital comparison and search module so that you can compare two fingerprints and mark up the identification points. And then finally, we have what we call a portable kit, which adds a couple of things to the camera to enable you to take it to the crime scene. That said, most of our customers will use DCS5 in the lab. It is designed to be a lab-based product. So the sort of things that you can do with DCS is make image enhancements very quickly and easily. So on the example you see here, we have an Australian banknote that has fingerprints. The fingerprints have been dusted with a special powder that reacts in the infrared. And then using the DCS, we're able to photograph in the infrared and see things that our eye cannot see. So when we look at this image, we can see a little bit of fingerprint detail in the lower middle part of the screen, but it's certainly not clear. But when we actually photograph this in the infrared using the correct illumination and the correct filters, we actually get an image like this, and that can be then enhanced further, and it looks completely different to the original image in the visible. And with DCS you can go from this to this in a minute or two. It's designed to be quick, easy and simple. So let's get down to see exactly how we use the DCS in action and give you an idea of the type of results that we would expect, and also the type of examinations that you can do with the DCS5 system.
Here we're going to provide an introduction to the DCS5 workflow. To begin, we are setting up the DCS5 to image a black powdered finger mark. We will place this into position underneath the camera, utilising an appropriate light source. Then we will adjust the camera on the stand to get the finger mark into focus. Here we have our main user interface for the DCS5 system. To begin, we're going to capture a preview image of our exhibit. We can then zoom in to check the focus, and also so we can view the finer details of the finger mark. If necessary, we can make adjustments to the camera settings, such as changing the exposure with the shutter speed or the aperture. We can also perform enhancements to our image, so we can also convert it to grayscale. Next, we will provide our case details. Here we will provide a unique case and exhibit name. Next, we will select our lens and the appropriate focal preset for that lens. This will ensure that we capture our image so it is calibrated to a 1:1 ratio. Finally, we will then capture our image. As the image is captured, it will be validated. This will ensure that any unauthorized changes to the image can be easily identified, and this forms part of the digital image continuity, which is integral to the DCS5 system. Here we have our captured image. The DCS software offers a range of different enhancement types. Here we have our enhancement toolboxes. This offers a range of different enhancements based on the type of treatment used on the fingerprint, or even the surface on which the fingerprint is on. Here we are actually going to pick our powder enhancement toolbox. We are going to perform a simple enhancement to increase the contrast of our fingerprint. Next, we are going to open the audit trail for our fingerprint. This will contain details of the computer and software. It will also contain all of the images, camera settings that have been used on the image. It will even contain information on all of the enhancements that have been performed on the image. This will be saved alongside your image. Finally, we will then output our image. In this example, we are going to output by printing our image at our 1:1 ratio. However, it is also possible to output to other areas. For example, you can send your image directly over a network to an APHIS computer. And here we have our image printed out. If we now measure our mark, we can quite clearly see that we have 1:1 calibration with our original exhibit. Here we're going to show you the visible fluorescence module of the DCS-5. Here we are imaging a drinks can treated with a fluorescent powder. This time we're utilising a different light source, the Crimelight Mark II. This is a light source designed specifically for use in visible fluorescence photography. Here we will select the appropriate light source for the treatment and the matching filter so we can view the fluorescent output. We will then enter the live view mode of the software, and here we can search our exhibit for finger marks, capturing a preview, and then we can zoom in to look at the finer details of our finger mark. The dark field ring light is a light guide which can be utilised for the illumination of three-dimensional fingerprints. This attachment provides oblique or angled illumination using our forensic light source, FLS. This will help to eliminate glare from samples whilst also improving the contrast of 3D finger marks. We place the dark field ring light around the finger mark, angling and tilting the light guide until the correct illumination is achieved. When the dark field ring light is used at the correct angle, it will almost always produce an image where the ridges are dark coloured and the furrows are light coloured. If required, your image can be inverted as part of our software enhancements within the DCS-5 software to produce the correct orientation of your fingerprint. Here we have our gooseneck light attachment with light provided from the FLS. The sample we are using today is a brown beer bottle. This type of sample can be especially difficult to image, especially when trying to create even illumination across the surface. With our goosenecks, we can provide illumination from two different angles, or even place a gooseneck inside of the bottle to create the illusion of a transmitted light effect. This light guide also has polarizing filters on the ends. As we are working with polarized light, we can adjust these filters to reduce any reflections or glare on the glass surface. The coaxial light guide can be used for the examination of reflective surfaces, such as mirrors, glass, or even reflective metals. Here we have a sample of a mobile phone. This has not been treated, but may contain some latent finger marks. The coaxial light guide provides illumination which will help to eliminate glare and reflections, a problem often faced when imaging finger marks on reflective surfaces. Here we have a finger mark captured from the mobile phone. First we are going to apply the grayscale enhancement. As we can see that the contrast of the mark is quite weak, we're going to perform another enhancement to improve this contrast. The paddle light can be used for a range of lighting applications, including transmitted illumination on samples such as lifted prints. In this sample we have a lift, and the light guide will provide even surface illumination from below, allowing for simple imaging on the DCS-5. This light guide can also be used for the process of specular illumination. Here we have a fire extinguisher which is untreated but may have possible latent marks on it. The paddle light can be moved so our light is angled, and utilising a long exposure within the DCS software, we may be able to take an image to visualise our marks. DFLS provides illumination in the visible and infrared parts of the spectrum over 600 unique wavelengths. Utilising one of our 6 light guides, FLS illumination can be directed towards the evidence and can be used for the removal of interfering background patterns. In this example, we have a piece of white adhesive tape containing interfering red block letters being examined. With visible contrast imaging, we can enhance a fingerprint in cases where you may have the mark on a coloured background. In this example, the fingerprints are over a red background, but we're able to use a red light to lighten the background, removing the interfering text and overall improving the appearance of the finger mark. We use the application of long-wave reflective UV. This is revolutionary and utilised on the DCS for supporting imaging of cyanoacrylate marks and some latent finger marks. In this first example, we'll show a common issue with imaging superglue marks on a white background. With white light, we would have no contrast between the mark and the background. However, when we utilise reflective UV, we can very easily see multiple marks across this. You may have noticed that we've made some changes to the hardware of the DCS5 and we are now using UV quartz lens. Now we are going to try and image a very difficult sample type. We have a pry bar that's been superglued. In standard practice, if you were to use a fluorescent dye on this type of sample, it is going to be very difficult to image. Therefore, we're going to try and use reflective UV to search directly the superglue. Here we have another common sample type. We have a drinks bottle that has been treated with superglue. Now, what's particularly important about reflective UV is that you do not need to treat your sample with a fluorescent dye. So here we are searching the bottle and we can see multiple fingerprints across it. Now, some of the key things with reflective UV that we need to consider. First of all, we use long wave reflective UV, and therefore it is very safe for you as a user to utilise this process. Another key point we need to consider is that long wave reflective UV will not denature DNA on your samples, and therefore if you want to take your exhibit through another forensic process, you'll be able to do this in the future. Here we have another example of using the FLS, but this time viewing in the infrared. Here we have a Red Bull drinks can with some finger marks on. However, the background is interfering with the finger marks. So in order to create contrast, we're going to move through the different light sources and into the infrared, removing the background and allowing us to visualise the finger marks. Here we have another example of using infrared light on a difficult background. We have a black powdered finger mark on a drinks carton. First we view it in visible white light, then we will move through the light sources and into the infrared, removing much of the background and allowing us to visualise multiple finger marks. Foster & Freeman's FP Natural fingerprint powder range will emit near-infrared fluorescence when illuminated with an appropriate light source. FP Natural powders can be used to treat a sample which may contain a challenging and sometimes interfering background, or where a high contrast fingerprint may be required. Here we have an example of a polymer banknote which we are going to illuminate first with a red light. We can see that there are some fingerprints present on this banknote. However, we are getting fluorescence interference from the background. Here we take a preview. We move back into live mode, change to an infrared light source, change a filter, and we can now see our fingerprints in live mode. Take a preview. And here we now have our image, where we can see the fingerprints, but the background fluorescent interference has been removed. In this second example, we have another challenging sample type. Here we have some wrapping paper that has been treated with FP Natural 2. First, we're going to place the IR light on with the filter in place, and we can now see on the screen that the fingerprints have appeared, and we are getting no interference from the background pattern. If we zoom in, we can see the incredible detail of the fingerprints. And here we also have another piece of hardware suitable for use with the DCS-5. Our CSU and PLT light tunnel are utilised for photographing cylindrical objects. Here we have a bullet treated with the LFT Recover instrumentation, which we are loading into the CSU-2. We're going to slide the CSU-2 into polarised light tunnel, and the polarised light tunnel will evenly illuminate the sample. We will rotate the sample. These types of samples usually can be quite difficult to image, but we are able to rotate the evidence, and the software will help us to unwrap your 3D fingerprint into a 2D image. The Wizard is a useful tool within the DCS software. If you are unsure of how to image your sample, you can use the Wizard to give you advice on how to do this. It can provide you with camera settings and lighting options optimal to the type of evidence or treatment that you are using. You can pick what type of sample that you want to process. So here we're going to pick a plastic bottle, and then the type of treatment that you have used on your sample type. So here we're going to pick BY40 after superglue. It will give you information on your camera settings, your lighting options, and then also some sample images. The DCS-5 software provides a variety of enhancements for your image. These advanced techniques include colour background removal for both regular and irregular patterns, removal of regular repeating patterns, and area of interest, where you can select specific areas of the image to enhance. And here we have our image taken from the CrimeLight Auto from the crime scene. We've imported it into the DCS and now we'll perform some simple enhancements. First we will grayscale and then invert the image. We will then move towards our enhancement toolboxes, finding the fluorescence tab, and perform a simple enhancement on our image. And here are our completed fingerprints.
So DCS in summary, it's the most advanced fingerprint imaging system on the market. It's designed to make your workflow simple and fast. It's designed to give you audit trails so that when you take your evidence to court, you're prepared and you can prove that the original images were protected and then a copy of the original image has been enhanced and explain exactly how the enhancements have been done. DCS enables you to get professional results in minutes or even seconds sometimes that would take you maybe hours using other techniques that are out there on the market. It's the most complete system. You can choose a basic system or, as your budget allows, add on to it to build up your system over time. DCS is used in over 50 countries around the world, and many of those countries have many DCS systems. It's been proven time and time again to be the industry's most popular fingerprint enhancement system. And with over 20 years of development behind it, you know that you're getting a world-class product.